Moving past broad stroke national level trends, let's look at some specific markets. The first one I'll touch on is CAISO. At a big picture level, CAISO's got a lot of renewables coming in, and it's got base load going out. So that's kind of the big picture. From a policy standpoint, clean energy target by 2045, with incremental steps along the way. The ones through cooling, driving a bunch of coastal thermal retirements. Diablo Canyon, the big nuclear plant, retiring in the mid-2020s. Storage just now starting to catch up, but it's still going to take a long time before storage can really catch up. So that's kind of the big picture overview of the supply in CAISO. Renewables coming in, thermals going out. Added to that, you can't really take a long-term view of CAISO without kind of understanding the regulatory and planning process. I think the planning in California from a resource planning standpoint is a mess. If you think about kind of two extremes, you could have a regulated market where you have vertically integrated utility and you have state regulatory commission, and the system is being planned, and goes through a planning process. And there are a variety of pluses and minuses with that, but it's at least fairly straightforward, and you can ensure that the system is being planned. You could also have a deregulated market, ERCOT being an example, but not the only, something similar to PJM as well, where you have a wholesale energy market, you have a capacity market or a capacity incentive like you have in ERCOT through the scarcity pricing. You have energy retailers and merchant generation all kind of playing in this world. So that's another model. California has kind of neither one, but both at the same time. And so, if you think about a regulated market like two hands on the wheel driving a car, and a deregulated market, kind of like a self-driving car where the market is doing the driving for you. California has like blends of both, and it's sort of like having a distracted driver. Like it's the sort of a self-driving car that's not good enough to be self-driving, but just good enough to make the driver not be in total control, which just gives you the drawbacks of both. So in California, you have split regulatory bodies. So there's CPUC regulating the IOUs, CEC regulating the munis. The CCAs have their own boards of directors, so they're kind of doing their thing, but they're also regulated by CPUC. They have to submit these integrated resource plans, which they may or may not follow. There's a split planning, so CAISO is the system operator saying this is the capacity we need, but CPUC is the one who controls the utilities on the system. You have a split in the retail energy, so you have the IOUs and the CCAs. The CCAs functioning like an energy retailer. The IOUs also selling energy to customers, but also running the systems. You have IRP processes for both, who may or may not be talking to each other and planning in concert. And so it's just a very complex regulatory and planning environment. And that complexity has consequences. And we saw some of those consequences last summer. So the ISO said, hey, we need almost 5 gigawatts by 2022. And so CPUC demanded 3.3 gigawatts. So kind of a misalignment. On top of that, the root cause analysis after the summer shortages last summer, one of the things they identified is that the reliability value of intermittent resources is still overestimated during the net peak hour. We, at Ascend, still find it quite strange that solar gets any capacity value in California. The shortage conditions are not during solar generating hours. They are very much when the sun goes down, when sun is not available. And so the net peak, that's where all the concerns are, and solar just doesn't really cover that. So that's an ongoing issue. Just recently, I just grabbed this off a utility dive this morning. San Diego Gas and Electric are pushing against one of these proposals from the CPUC about replacements for Diablo Canyon. And one of the proposals is basically that the IOUs, basically San Diego Gas and Electric, SoCal Edison, and PG&E, they're going to have to buy thermal generation and nobody else will. And yes, the cost would be shared, but there's a definite possibility that could drive more people to leave, more customers to leave those utilities and go towards the CCAs. And so what they said in there, or what their attorney said, is that the Commission's historical approach of imposing on the IOUs disproportionate responsibility for implementation of the state's policy imperatives is inappropriate given the advent of customer choice and completely unsustainable given increasing levels of load departure. And this kind of goes to this sort of split retail model with the IOUs running a lot of thermal generation and the transmission systems and the distribution systems, while the CCAs are providing retail energy. And so it's just a very, very complex regulatory structure, and it leads to some planning gaps. And I think those planning gaps are likely to continue. There's also, the issue that we saw last summer, which was that, there was a reliance on imports that weren't available because there was a heat wave through the whole region. So, what's the future planning paradigm for California if imports aren't as reliable, and they have a renewable mandate, but they don't have great wind resources, and they're very solar heavy, and they have the split retail model, split planning incentives, and storage is starting to come in, but it's going to take a while to catch up. I think there's likely to be a very ongoing reliability struggle in California over the next several years until the planning process starts to get better integrated with the reality of the supply mix. Some other geographic factors that are really important to understand in California. Over the last few years, we've seen peak prices increasing on the coast. That's really driven by some of these thermal retirements of the once through cooling plants. We've seen more volatility on the coast. Another really critical part of the story is the basis differentials that we're seeing. As solar comes into the kind of southeast desert, and as those retirements happened on the coast, we saw a bifurcation in basis where the coastal basis got up higher and higher, and these bases out in the inland desert became more and more negative. If you look solar weighted basis, some of these nodes out here around Blythe are like -10, -12, -15 bucks. So really, really huge negative bases because this area doesn't have a lot of load and it's got a lot of generation and it just gets oversupplied. So we've seen that as an increasingly common dynamic. And as we see floods of solar coming into different parts of the state, we expect kind of similar dynamics to start to emerge. The next two big floods are Tehachapi and the Central Valley. So we also have to think about the future dynamics of prices. This graph on the left of California, this map is price volatility. And so if you are trying to site a storage project, you want to be where prices are volatile, because high volatility means lots of arbitrage opportunity, right? So we see a little bit of volatility here around Fresno, some volatility around Palm Springs, a lot of volatility around San Diego and on the coast. These are all volatile today. But the question is, are they going to be volatile moving into the future? And so we have to understand, this is a great site now, but what's its future prognosis? And one really useful indicator for that is the day-ahead basis. So where you have negative bases is typically where you have not a lot of load and a lot of supply, which tends to be wide open spaces. And so these are places where if you add some storage, it's probably going to make a really big difference because there's not a lot of other load around there. And it's also going to be pretty easy to build because you have open land. So when we look at the future of volatility, these areas like Fresno and Palm Springs, they might be volatile now, but that volatility is easy to mitigate. And so we don't expect that volatility to be there moving forward because it's too easy to build stuff in that area. And there's not enough upward push from load to sustain that volatility. If we look at San Diego, on the other hand, that volatility is much harder to mitigate because it's harder to build, it's harder to site, there's less available land, there's a lot more load. And so that volatility we expect to last much longer than the volatility in some of these inland spots. We also see a lot of price depression in California. If you look at average prices as a function of renewable penetration, they plummet. And once you get to about 50%, they go negative, both real time and day ahead. And so, as you look at California moving towards 60, 70, 80% on average, just think about this. If they get to 50% on average, that means they're going to be spending a lot of time up here in the 60 to 80%. And those prices are almost certainly going to be zero. We expect more and more and more curtailment and negative prices in California as we move forward, particularly during the solar generation hours. You can see in this graph here as well, percent negative prices versus renewable penetration. And you can see that, really starting to take off around 50%. This is 50% in the moment, right? So when you get to 50% on average, that means you're living out here in 60 to 80 quite a bit. So that's an increasing part of the story. If we look at curtailed energy in California, 16, 17, 18, 19, 20, rapid growth. A lot of the curtailment is happening here in the spring. As you get more and more renewables onto the system, that's going to spread further and further into the summer and further into the winter. Our forecast for CAISO, we think on-peak is going to be the new off-peak. We expect on-peak prices to drop below off-peak prices by the late 2020s. And this is really driven by more and more solar leading to more and more curtailment. So those on-peak hours are going to get pushed down and down and down. And at the same time, you've got carbon prices in California continuing to escalate. As you get curtailment, those carbon prices are going to have less and less effect on the on-peaks and more effect on the off-peaks because there isn't a lot of clean off-peak energy in California. So our expectation is that, within about 5, 6, 7 years, you're going to see these on-peak and off-peak prices converge and cross. We also think, I don't think we're the only ones who are saying this. Everybody who's looking at California is expecting price shapes to get more and more ducky, that belly to get pushed down further and further. So that's very much, part of our expectations. We think as storage starts to catch up in the late 2020s, that this will start to snap back a little bit, not all the way, but a little bit. As we look at RA, we think that RA is increasingly going to be defined by storage in terms of the price setting. And you can't look at kind of the RA value of storage without looking at the ELCC of storage. So what's its capacity value going to be? CPUC has already done some modeling to look at what duration you would need basically as storage takes up more and more of the supply stack. So CPUC is already expecting that capacity value to decline as storage penetrates in. So our RA forecast for California is that 4-hour battery is going to get declining RA value as its capacity credit declines. And that declining RA value will cause a long-term kind of slow growth in the RA prices. For volatility, we've talked a little bit about equilibrium in the past, and this green line here represents the amount of volatility that you would need in a market to make economic sense for storage. Blue is what would happen, is what we would forecast would happen to the volatility if storage didn't start to catch up and eat its own, kind of cannibalize its own opportunity. So what we expect for California is that volatility is going to grow for the next couple of years before the storage starts to catch up and really bring it down to an equilibrium level. And what's really going on here is that even if you look at all the renewables like solar plus storage projects in California, those solar plus storage projects are typically storage at less than half or maybe around half of the solar capacity. So, if you have 100 megawatts of solar and 50 megawatts of storage, you're adding at least 50 more megawatts of solar into the grid, which is driving more volatility. So we expect that volatility to continue to grow until storage catches up and then bring it back down to equilibrium. And the reason that you see this departure between our forecast and equilibrium is that there's just that slow project permitting pipeline. And so it's going to take time for storage to catch up. Just to summarize California, the planning process is complex. Tight capacity is probably going to be an ongoing issue for the next few years. A lot of renewables are continuing to go into the desert, so basis risk is continuing to be a huge issue. We expect a lot of volatility is what it comes down to. So it's a great opportunity for storage, but the timeline to get a project built is always going to be a limiting factor. So that's CAISO. The next one I want to jump into is ERCOT, and then we can pause for a little bit of Q&A before we jump into some of the other markets. So ERCOT is interesting. I don't think many people have a full appreciation for the scale of change that is happening in ERCOT right now. If you look at what's in the interconnection queues, over the next, it says 3 years, it's really over the next 2 years, ERCOT is going to add about 10 gigawatts each of wind and solar. And that's not based on everything in the queue. That's based on what's in the queue and has posted financial security. There's a lot, and there's a lot that's already come on. Solar has put on, I think, about 3 gigawatts last year, and then was even between the Winter Storm Uri and now was projected to add like another 4. There's a lot of solar and wind coming into ERCOT. And there's already a lot of solar and wind coming into ERCOT. So even just over the next 2 years, we see a big surge in wind and solar coming in. Look at the interconnection queue, wind in green, solar in yellow, tons of wind and solar coming in, tons of wind and solar coming in with some batteries as well. So the question is, what is that going to do to the market dynamics? Well, there's a few things it's going to do. But before I jump into that, I want to talk a little bit about kind of Winter Storm Uri and what we think kind of some of the landscape is as a result of that. When we did our extreme events workshop a couple of months ago, what we said that we think that ERCOT should do is not introduce capacity market yet. Designate gas production distribution as critical infrastructure, enact a winterization mandate, tighten building codes, and increase interconnections, particularly to the east and the west. We didn't think they would do that. We just thought they should. The ones that we thought they would do were these top three. And what we've seen is that this is pretty much borne out. So there is not plans to introduce a capacity market as we expected. There were also a couple of bills recently in the Texas legislature. One was really a requirement to improve communications between the gas supply infrastructure, basically the Texas Railroad Commission and ERCOT. Kind of to try and help coordinate better and designate that critical infrastructure and plan better around the supply system. We also did see a winterization mandate. I don't know exactly how it's going to be funded or enforced, but there was some legislation that got passed. So we've seen some things in response to Uri. How often I think Texas is going to be a winter peaking system. I think we're still a very long ways before anybody's worried about Texas being consistently a winter peaking system. But we'll see. We'll continue to keep an eye on what happens there. I'll talk a little bit more about capacity markets in Texas in a little bit once I talk about some of the market dynamics with solar and wind. In terms of geography, there's really only one big story. And the big story is that with the amount of renewables that are coming in, particularly in West Texas, this kind of west to east corridor is going to become increasingly transmission constrained. We saw this in 2013, 2012, by the way, when all the wind was coming into West Texas and there was negative prices. Then there were some major transmission upgrades to bring a lot of that power into the east. And I think we're going to hit the same dynamic again. When we look at an east to west corridor that's already constrained, and now we're dumping a ton more wind and solar into it, it's just going to become more and more constrained. And so that's going to increasingly going to be a risk. We're going to continue to see price premiums on the coast and on the borders because that's where you just have limited supply options. So you just have fewer resources available. Talked about in California, easy to mitigate volatility versus hard to mitigate volatility. Same story in Texas. When we look in the West, we see some volatile areas, particularly up at the interconnect boundaries and down here in fracking territory. But the problem is that these are wide open spaces, lots of negative basis, not a lot of load. Makes it very easy to build transmission, to build storage, to kind of mitigate some of that volatility. And so I wouldn't count on this volatility continuing to be a premium. Where the volatility is much more likely to last is down here on the coast and in the southern tip. Here you just have limited supply options. You got water on one side, you got Mexico on the other. There's just less available. And so this volatility is much more likely to stay strong. I mentioned, kind of that basis from west to east. We're already seeing that in curtailment. This graph on top, this is solar curtailment for the last couple of years, increasing, rapid increase this past year, or this year, 2021. Wind curtailment increased a little bit, but one of the things to note here is that wind curtailment is going to be much less because wind can bid the negative production tax credit, which means that if you've got west solar and west wind both competing to get through the same transmission constraint, solar much more likely to be curtailed than wind. So understanding your curtailment risk for solar in West Texas is really, really critical, particularly because wind can outbid you negative. So solar is going to be curtailed before wind when there's a transmission constraint. Another thing that we're seeing in Texas is with the amount of solar coming in and the pace at which it's coming in, CAISO's duck shape took years to form. ERCOT's duck shape is probably going to happen within the next year. We're already going to see some pretty significant Ducky dynamics. It's going to look different because in CAISO, you're always handing from solar to gas basically as the sun sets. But in ERCOT, you've got wind in the mix too. And so there's going to be a funky period, particularly in the couple hours between sunset and between the wind picking up, where we're likely to see some very funny price dynamics that are sometimes going to be extremely high and sometimes going to be negative because there's uncertainty around what the wind is going to do. But you should fully be expecting price depression midday as a result of solar build out in ERCOT. And we're already seeing some things happening. So this was April 11th, just a couple months ago. What this gray line is the amount of flexible capacity in the ERCOT system. So how much ramping capability does it have in the next 5 minutes, basically? And so what we see is that when the sun sets, if the wind drops off at the same time, you get these huge net load ramps, and those net load ramps can put a severe strain on the flexibility of the supply stack. And they actually went down, and this is called a power balance violation, where they went down into zero and negative territory where they didn't have enough resources to actually meet that ramp. And what they had to do instead is they had to lean on their ancillaries. And there's a pretty severe price penalty that goes with doing that. In the power balance violation, and so prices jumped up to $2,000 a megawatt hour as a result. The only reason this is 2,000 and not 9,000 is that the 9,000's already got used up in the February storm. So this would have been a $9,000 price spike event otherwise, based on this power balance violation going negative. So we're already seeing some of these net load issues in ERCOT, and it really comes down to what's happening with the wind. So this was about a week later. What we saw is that on the 17th, April 17th, the sun went down and the wind went down at the same time, and we got a price spike. On the next day, the 18th, the wind goes down and the sun goes down at the same time, and we get a price spike. On the next day, sun goes down while the wind is going up, and not only do we not get a price spike, we get a huge dark spread. So day ahead price is much higher than the real-time prices because that wind is doing more generation than expected. And so we expect some of these really funny dynamics to continue in ERCOT. Great opportunity for storage to be available to mitigate some of this solar to wind handoff, because we're already seeing these net load ramps that are really stretching the system. In terms of prices, we see prices declining both on peak and off peak. This period here, kind of 2020 to 2025, this is market forwards. So the market forwards are expecting a price decline. And that price decline in the on peaks is much larger than the off peaks. And that's really being driven by that solar build out. As I mentioned earlier, in our long-term forecasts, we do assume a carbon price. Our carbon price assumption is a 5-year phase in from 2025 to 2030, followed by an escalation to about $20 a megawatt or $20 a ton. Our expectation here is that there's a very high probability that there will be zero national carbon price. There's a small probability that there could be a very high carbon price, like $100 a ton. And there's, maybe a slightly higher probability that there could be bipartisan support for a low carbon price. And so this is our best attempt to kind of mitigate very, very bimodal distribution of potential outcomes. So that carbon price kind of buoys things and pushes our prices up in our forecast a little bit. Otherwise, our prices would continue to decline. We also have a price shape forecast where we are expecting, duckiness to continue to set in and more severe midday price depression. So we expect that to be a continuing issue. We also are thinking very carefully about where scarcity is going to show up. And right now, ERCOT, like yesterday, ERCOT's going through some funny dynamics because they have a lot of thermal generation that's unexpectedly offline. But in general, the system's going to be long with all the solar coming in during solar hours. The tight conditions are almost certainly going to be in that couple-hour handoff between the solar and the wind. So where scarcity is most likely to show up is also a place where negative prices are likely to show up as you kind of manage that uncertainty of the solar to wind handoff, which is a very different dynamic than California. Our volatility forecast for ERCOT, volatile, continuing to be volatile. We expect a disequilibrium period in ERCOT as well, with prices kind of coming back to equilibrium around 2030. but the pace of renewable build out here is very strong, and it's going to be hard for storage to keep up. So big story, renewable penetration coming fast. Fast is the key thing. There's a lot coming in really quickly. Price depression is happening, but volatility is going to continue to grow. We're already seeing these new net load ramp volatility events that didn't used to be there. That's only going to increase and continue. So great opportunity for batteries, RICE units, even combustion turbines. Ducky price shapes are important. Everybody 3 years ago was looking at the price dynamics and saying, wow, solar looks fantastic. Everybody saw that. Everybody started building solar. It's going to look less fantastic moving forward. Still looks decent, but you have to be aware of those Ducky shapes and what their impact is going to be. We also see so much coming into West Texas that we're just going to see a lot of congestion and a growing basis risk, particularly compared to the load centers in the east. So the West hub is very likely to continue to show a lot of price depression relative to the others. So we got to be cognizant of that. I expect ERCOT at some point in the next few years will do some pretty significant upgrades to some of those west to east and west to south corridors. But there's going to be some congestion before that happens. But great opportunity for flexible generation and storage. So let me pause here and do maybe just a couple questions Q&A for ERCOT in California.
Carlos, I want to unmute and take the first one. There's one that you wanted to take yourself.
Sorry, Tom, I'm having a little bit of trouble hearing you.
Okay. Carlos, Carlos, can you unmute and take the first question? Okay, I'll roll into the next one then. Okay. We have a lot of ITC questions. I think we hit that pretty hard last time. In a future state that includes greater market price volatility, what market changes, e.g. new products, reliability requirements, do you anticipate or expect to see evolve?
Yeah, we touched on this earlier with ancillaries, the potential for a ramping reserve product or an imbalance reserve product likely to be part of the picture. I think there's a question of how much is a ISO going to trust its own market signals. When we look at these hyper volatile prices, what that screams out to people watching the market is that we need flexible resources that can respond to these extreme, volatile prices. And so, there will be flexible resources that'll see that opportunity and come in. The ancillaries kind of help stabilize some of that, so you can kind of have a little bit less volatility with a little more guaranteed revenue as a result. But the price signals send a pretty clear message for what the system needs, and so there's an opportunity to really let those price signals speak for what the needs are.
Okay. Next one from Steve Brown. It says, since thermal and nukes have fairly high fixed costs when cap recovery is included in the calculus, how will markets like ERCOT, which you just covered, incentivize this critical support to reliability of the grid?
Yeah, so ERCOT, I think, is a very interesting one. So, I think that ERCOT, as more and more renewables come in, they're going to take an increasing part of the energy share, which is going to cut into the capacity factors of everything else. They're also going to lead the system to be oversupplied and not having a scarcity for a little bit of time. And so that's going to put severe economic pressure on the thermals in ERCOT, and they're likely to start retiring. As they start to retire, the system is going to get tighter, and then we're going to see scarcity come in. And I think ERCOT, if it doesn't implement the capacity market, ERCOT is going to enter into a very wild period of instability and scarcity pricing. So, I said that we didn't think they should implement a capacity market yet. I think they may need to, as thermals get forced off the system with the amount of renewables coming in. We'll have to pay attention to see what happens, but how much tolerance they're going to have to that instability, I think, is a very interesting question, because I think things are going to be unstable as thermals are forced to retire, because it's a merchant market, and so there is no rate recovery, right? And so I think it's going to be very interesting to see how that plays out and how much tolerance there is to ongoing scarcity. When we look at some of the other systems, PJM is planning on doing an ELCC-based approach for its capacity accreditation. I think that's wise. And as more and more renewables come in, they'll get less and less capacity credit. And so you'll have a capacity auction that will ensure that you have sufficient capacity and reliable resources to meet your needs. I'm a little worried about the nimbleness with which ISOs will be able to adjust the way that they do ELCC modeling. Remember earlier in the slide deck, I talked about how critical conditions may be evolving. How nimble are ISOs going to be in recognizing that the critical conditions that they planned for 2 years ago may not be the critical conditions now. And so I think that's very much a concern. We're already seeing it in CAISO, the overvaluation of solar capacity being kind of case in point. Hopefully other ISOs are going to learn from what the leading ISOs figure out as they manage kind of these higher renewable penetrations. But if you have a market that can appropriately incentivize reliable capacity, then that's your mechanism for ensuring that reliable capacity stays online. But having the appropriate capacity auction or capacity market will ensure that you're actually incentivizing the lowest cost resource to complement everything else. And whether or not ISOs can do that is also an open question. There's, if you look at PJM or MISO, there's a lot of utilities that have kind of some vested interests in keeping their thermal generation online. And so, who does the market serve? Does it serve the customers or does it serve the utilities? And that's an ongoing issue as well.
One more ERCOT question. What are your thoughts on ERCOT projecting a 0% storage contribution to peak demand through 2030?
Well, so ERCOT doesn't have a capacity market. So, if they undervalue storage, then they will lead people to over-expect scarcity revenues. I think 0% is absurd. The question is, what duration will you need? I think ERCOT is very likely to need 2 to 3 hours of duration for at least the next several years, maybe moving to 6 hours or so by 2030. But the question is what is the system going to need, and how long is it going to be short, and what are the shortage events that lead to scarcity prices? And so it doesn't really matter what ERCOT thinks. What matters is what scarcity conditions arise, and so we'll see. I think it's very likely that 6 hours will be more than sufficient through 2030.
Great. One last one. This is still ERCOT. Do you forecast that energy arbitrage will be a main revenue source for BESS in ERCOT? What typical revenue stack percentages would you consider for ancillary services versus energy arbitrage?
Yeah, so as I mentioned earlier, and as Gary kind of touched on as well, our expectation is that as those ancillary markets saturate, then the prices are going to drop down to a level where they reflect the opportunity cost of energy arbitrage. So basically, like, you be indifferent one versus the other. Like your effective revenue from ancillaries is going to be equivalent to energy arbitrage, because if ancillaries were more valuable, nobody does energy arbitrage. If ancillaries were less valuable, nobody would do ancillaries. And so in the long run, those need to be roughly in equilibrium with each other. So whether you look at ancillaries being in the stack or arbitrage being in the stack, either way, we see them as being roughly equivalent revenue sources. In addition to that, ERCOT is implementing real-time co-optimization. It was originally targeted for 2024, but they're looking at moving that back. Very likely it's going to be 2026. But at that point, there isn't even really any true opportunity cost, because you can buy yourself out of ancillaries and provide arbitrage. But arbitrage, we very much expect to be, the key value driver, and ancillaries being roughly equivalent, because they'll be in equilibrium with each other.
Terrific. Here's one for a California question. This is from Cristiana Santa Lucia. Can you go back to the California RA and clarify if 8-hour storage resources would experience the same drop off in RA prices after 2025?
Yeah, so our expectation in California is that the duration is going to continue to increase, the required duration. You know, when 4 hours is getting 50%, 8 hours will still be at 100. And 8 hours wouldn't be less than 100% until 4 hours drop below 50. So really what we're saying is we expect that required duration to ratchet up over time from 4 to 6 to 8. We expect 8 hour to be full capacity at least through 2030.